So, hello once again. Good evening. Welcome to another Cyber Shuja mentorship session. It is good to see all 50 of us on the call. So the rest can just join us as we go. Today we'll be speaking about generative AI, and with us is Kimani, who will be taking us through this particular session. He is a data scientist, lead Generative AI Squad at Safaricom. He'll tell us more about himself, what he does, and also take us through this. So, karibu sana Kimani to the Cyber Shuja mentorship session.
All right. Hi everyone. I'm glad to be here. Let me turn on my video. And I'll be glad to take you through what generative AI and what I do on a day-to-day. And also feel free to ask so many questions. So allow me to share my screen so I can start. Right. Do let me know what you can see on my screen. Are you able to see? Are you able to see my presentation?
Yes.
All right, perfect. All right, so as Hope has introduced me, my name is Kimani Kibuthu. So I am a data scientist by profession and currently have the opportunity to lead the generative AI team at Safaricom. And today I'm happy to be here to showcase to you what generative AI is. But first and foremost,
with this number of years experience as a summary, so that they can see, this one was already graduated. But part of the reason why sometimes.
Yep. So I titled my presentation AI, it's electricity for the 21st century. But for the 21st century. Why? Imagine how electricity was very impactful in the 19th century and the 20th century. It became so impactful that right now we cannot live without electricity. And that's what AI is becoming. And this is the reality that we face when it comes to the 21st century. So what we'll cover today is that we'll cover the AI landscape. So understand from machine learning to generative AI, and also where did machine learning come from? And then also cover what Gen AI can and also cannot do, some real world use cases and architectures, then a live demo where we'll get to play around with some of the cool toys that are out there around generative AI, the skills roadmap, as well as open it up finally for Q&A. So there was a fundamental shift that happened, and this fundamental shift happened when we do have traditional programming, but in addition to traditional programming came machine learning, which was quite a huge game changer. And why was it? In traditional programming, and I believe most of us here are programmers, you do know that you have to have data and a program, you give it to a computer, and then it gives you an output. So what that means is that we write the rules. But in machine learning, what happens is that it shifts. You give data and the output to a computer, and it comes back with a program. Meaning, we show it examples, it generates a rule. And that's the difference. In traditional programming, the computer, we write the rules. In machine learning, the computer learns and generates the rules. So now with knowing the difference between these two, where does generative AI fit in? And I know you've heard many words. You've had AI, you've had machine learning, you've had deep learning, you've had generative AI. So you often can get confused, but where does it generally fit in? So think of it as, let's say, in circles, and it starts from the top. You see my presentation from the top left. So artificial intelligence is the whole body encompassing everything. So it is any technique that equips computers to emulate human behavior. So anything that you hear out there, generative AI is artificial intelligence. Machine learning is artificial intelligence. Artificial intelligence is a whole body that encompasses all this. All these other things are just but a subset of artificial intelligence. Machine learning, as well, on the other hand, is a subset of artificial intelligence. And what happens here is that where you are able to give data, where you enable computers to learn from data, where they identify patterns and are able to give us an output based on those patterns. That's what machine learning is. Then, when you go to deep learning is a subset of machine learning. And the difference now with this is with machine learning, we saw that you're giving a computer, in this case, we call them algorithms, you give them data and they're able to identify the patterns within the data and therefore come up with an output that can be used to make a decision or not. Now, deep learning does the same thing, but now what differentiates deep learning and makes it a subset is that it's because of the architecture of the algorithms used. And here, the algorithms used try to mimic the neural networks that we have in our brain. And that's basically what differentiates deep learning from machine learning. And last but not least is generative AI. And generative AI is a subset of deep learning. And what it does and what makes it generative AI is in its name, where it generates context. It could be content, it could be text, it could be images, and even code. Any question? Right? So feel free to interrupt me in the middle of the presentation if you have any question. So what makes generative AI different? So what makes generative AI different is from traditional AI, and that's the machine learning and the deep learning that we saw previously, is that traditional AI is very narrow and specific to tasks. So for example, you may have heard of sentiment analysis that will either understand whether a tweet is toxic or not. You can train a model to do that, but that model will not do anything else. You can train a model to classify an email, whether an email is a spam or not, but that model, if not trained on other data, will not be able to tell you whether the sentiment of a tweet is toxic or non-toxic. So no, traditional AI is sort of very narrow and specific to tasks. Yeah.
I feel like you're scratchy. Is it on my side or you're not that clear?
Is everyone facing the same thing?
You are clear enough.
I can also hear you clearly from my end.
All right. Thank you, Victor. Thank you. Thank you for the feedback. So it is very narrow and it's very task specific. But when you go to generative AI, it has broad and creative capabilities. You can be able to do a lot with just one model. And we call these models foundation models. And I know most of you have played with these models. You've played around with either ChatGPT, you've played around with Claude, DeepSeek, name them. There's so many out there. I know you've tried all sorts of things. You can tell it to write you a letter, it will write you a letter. You can tell it to change your image to look this particular way, it will do so. It can do much, much broader tasks. Because one, it's trained on a lot of data, and two, it's generative. But we need to clear up some misconceptions. Having interacted with generative AI, there are some misconceptions that have come up. And there are so many fears and people lie on so many domains. Some are very pessimistic, others are too optimistic. And therefore, it's very good to clear up some of those misconceptions. And some of the misconceptions is that it will replace humans. So when this thing generates content, it may not be as smart as you. It doesn't do it's not multifaceted as you. You can imagine if you live here, you are able to leave your home after cleaning the house. You're able to cook yourself breakfast. You're able to go to school to learn. You're able to converse with your friends. You're very multifaceted. These models cannot do that. So it's not a replacement for humans. It's an intelligent assistant. And one thing you need to sort of start thinking around, which is really powerful, is that now what it does is that it augments you. It augments your capabilities. Where if you will be able to do something in, like, say, 5 hours, you can now be able to do the same thing in an hour. If you will write an email in 10 minutes, you're now able to write that email in 1 minute. It augments you and augments your capabilities. I have an interesting story that I had from one of my friends who's a cybersecurity expert, and they were letting me know that a long time ago, you were able to classify attackers into various groups, and you're able to know that the amount of time it will take an attacker to move from one group to another. Now with generative AI, it's a bit hard to know because it takes a much shorter time for an attacker to move from one group to another. So as much as that is scary, but it shows cases to you that if it took you, say, 5 years to become a senior developer from a junior developer, it can now take you less years if you really use this thing to augment you and to make you learn better, learn faster, and do greater things. The next is that it's not perfect. So we've had the term hallucination. So at times it can hallucinate. You can ask it a question, and because it's built to generate. And how it generates is that it looks for the next probable token. So from your prompts, it looks for the next probable word from that prompt. So it's bound to hallucinate. So, and requires a lot of human oversight. I don't know if you are able to see, you're able to, you've interacted with some of these models, especially GPT when it was starting. You could see at times it tells you things that are not quite true, right? And it's because it will not say I cannot generate this. It will be, or it's not generate, it doesn't know, but it will try and look for the next probable token, the next probable word to respond to you. Last but not least, it's not a magic solution. It's not going to do everything. When you give it garbage, it will still give you garbage. Remember, generates from the next probable word, and therefore, the more crisp your words are, the better it generates. The more you tune it properly, the better it generates. But on the positive side, a research that was done by JP Morgan estimates that Gen AI could increase the global GDP by 7 trillion. And this is crazy to see because a lot of impact is happening. A lot of growth will happen in businesses, but not only in businesses, but also in content and how content is generated. I don't know if for those who are in TikTok, you've seen some time ago there was these cool videos of, like, say, monkeys doing a podcast like Joe Rogan, and you would find that some of these things, how they've been generated, is just someone brilliantly just connecting Gen AI and in an interesting way where it's able to, one, pick up content, pick up information that's currently trending, create a whole script around it, and then once it creates a script, another one generates videos of monkeys doing that script. And this is something they can do in their sleep, and it will attract millions of views, and you can imagine the income this person generates from that. And that's how generative AI can be used to generate income in some of the few ways. And the things that it does exceptionally well, it generates, as you've spoken, it can summarize, like, say you have say you're going to a meeting in 30 minutes and there's a whole 60-page PDF you have to go through. You can tell it to summarize to you and give you the most important points that you need to know in those 30 minutes. It can transform, where it can help you change things between formats. Say you are writing code in Python, but it needs to be in Rust. You can have it look into your code base and help you transform that code. It can extract. You're running an invoice company and you want to always, you're running invoices in your company and it's very manual to take information from those invoices. You can have generative AI take you pass those invoices into the model. It extracts those information and returns in a JSON that you can save somewhere and act on them. And as well, you can converse. It's mostly big. You can use it to converse. You can use it in customer support and question and answer systems. And a lot of the use cases are mostly built around this. And we shall have a look at some of the categories that are around this. So you have the level one, which is data transformation. So you can tell it to change something from one to another. You have another level, which is where you are trying to create a natural language interface where you want it to chat with someone, for example, like in customer support, or the way you just interact with it in or like a personal assistant, or the way you interact generally with Claude or ChatGPT. The next is workflow automations. So you can pipe it to do to automate some of your processes. So say the one I said around invoicing, invoice management, you can create a pipeline such that whenever an invoice comes in, that happens and then does something. It saves the data somewhere. The one I mentioned on TikTok where uh, it goes once every day and checks scripts the scripts the internet for trending topics, and then creates a script and then does this and then does this. So those workflow automations as well can be done with Gen AI. And another one is where you have copilot and assistants. So, for example, say you have an email assistant. So it goes through your emails as you sleep, and then it tells you which ones you need to act on, which ones you don't need to act on, and which tasks are due, etc. So having this is a much more complex one, and it's a very exciting one and very impactful one. And last but not least is having autonomous agents. And here is where you give them full autonomy, like research agents. You can just have an agent that knows they can give the persona of, say, a McKinsey consultant and tell it to research on a certain topic, and it does that research and it generates for you an amazing report that's McKinsey standard. So this, from level one to level five, they range in complexity, and also based on in each of them, as much as they're complex, it doesn't mean that level five is the most fruitful compared to level one. It all depends on the particular use case. So we've seen those levels, and they're basically built around three architectures on a high level. I won't go into the depths of it because each has its own intricacies. But generally, what you can have is you can have direct API calls. And what this means is you send a prompt to an API of the model. So say Claude API, and you just use that for inferencing. So you send a prompt, and then the model gives you a response. So for example, a simple use case for that is, say you're trying to extract information from receipts. So in this case, what you'll do is that you can just give a very detailed prompt to a large language model and tell it, you're an expert receipt analyzer, and I want you to extract this information from the receipt, and I want the name, and I want the amount, and return it in JSON format. And here's the receipt that you need to do so. And send this prompt to the Claude model, Claude API, and it returns an output where it's the JSON that has the name and the amount. So that's an example of direct API calls, and they can vary around that. The next is retrieval augmented generation. And what retrieval augmented generation is where you are able to give, so these models, what happens is they are trained on the internet's data. And at times they may not have the context of your own personal document. So for example, I could have my notes that I have stored over time, or say a journal that I have, or say if I work in a company, some manuals that I have. Those are not, the model does not have access to this information. So how do you give the model this information? And that's where retrieval augmented generation comes in, where you have an architecture where you enable the model to retrieve the right information from your documents into its context so that it can answer you. So how this is often done is with the help of things known as vector databases and also some embedding models. So what happens is you take these documents that you have, you create chunks of these documents, and from these chunks, you create embeddings from them, and then you store these embeddings in our vector database. And then when you give a query, what happens is that your query is then embedded, and then the similarity of your embedded query is compared with, is searched through the vector database, and then the chunks most similar based off that similarity are brought up, and those are then fed into the context of the model, and the model can then use this context to answer you, meaning you can then get answers from your documentation through the model. So that's retrieval augmented generation. And it happens, and there's so many architectures around it, and I'd encourage you to go and read deeply into it, where you can have agentic RAG, you can have naive RAG, you can have so many ways of doing RAG. And they're out there, so many ways of doing RAG. And it's all dependent on your use case. And what happens is when you're building this, is you realize as you're building, there's no one shoe fits all. And that's something we say when in data science, we call it the no freelance theorem, where there's no one thing that will kill everything. So it's very much dependent on you, on the use case that you're dealing with and the problem you're trying to solve. And you'll play around these various facets, and you have to pick whatever works for that particular use case, and what works for them may not work somewhere else. And last but not least is agentic AI, and you've heard this a lot. And what happens is that now you use the LLM as a brain, and you augment it with other functions. So how I like describing agentic AI is taking you as a human being, for example. You do various things. And let's take an example of when you're working. When you're working, you need a computer. And in the computer, when you open the computer, to do certain things, you have to use certain tools. So for example, if you want to send an email, you have to open Outlook. You have to have a computer, open Outlook, think about the email you want to write that email, and then send that email. If you want to program, you have your popular IDE. You open up your laptop, go to that IDE, you code there. You definitely have tools that probably you're testing, etc. And you get your work done using these tools. And that's what agentic AI is. You augment the large language model with this same ability, where you give it instructions on what it needs to know what to do. And then you augment it with several things. You give it tools, you give it memory so that it can be able it's able to do all these things, right? It's able to save what it's doing and keep it in track, right? So what you find in agentic AI is also several architecture, and it's all dependent on your particular use case. Now, what you realize is as you're building AI, it's very important to use it responsibly. With great power comes great responsibility. And also, what I like to say, especially when you're using generative AI, with great power comes
great vulnerability. And you have had situations where a chatbot has, I don't know if you ever saw those stories, but for a car dealership, it sold to a person a car at $2. In another instance as well, it divulged company information through prompt injection. In another in another place you find, and this was a recent story. It was Deloitte, I think in Australia, where they realized it was AI generated information and it cost them a lot of money. So, how do you then ensure that you are not vulnerable whenever you're using these models? So, some easy do nots is when you're using public large language models. So, right now, when you log into ChatGPT and try using it, do not feed it with sensitive data. Do not feed it with any sensitive data. And what I believe sensitive data is, if you do not want it seen by other people, do not put it there. Because what happens with these models is that over time they collect what you give them and they use it to train the models again. So meaning there's a possibility that your data may be exposed for someone else to view. The other is closely related. So do not put customer data, especially if you're working with customers. Do not feed them these models. And the other one is do not trust AI output without verification. Always verify the outputs or put mechanisms that verify these outputs. So what do you need to do? Instead, read and understand the usage licenses. So whenever I know when you get that terms and conditions, you skip it or you agree. For these large language models, just try and read and see how they're using your data, especially on the privacy bits. Next, validate the AI outputs before using them. So whenever it's generating for your report, just go through that report to make sure it makes sense. As we mentioned, it's not there to replace you. It's there to augment you. You are still the one who was supposed to do that, but now you have a tool that's enabling you to do that. So don't be lazy. Just go through it. And why it matters is you do have the prompt injection risks, you have sensitive information disclosure, and also you could also have that data leakage concerns. So I'd encourage you as well to do go through OWASP top 10 for LLM applications. It's very interesting to know what those are, and it will really, really help you as you're building with generative AI. Now, let's go into the demo where I'll show you something interesting that you can play around with. Probably most of you may have played around with it. And yeah, let's do something with it. Let me know once you can see my screen. Give me a thumbs up. Perfect. Thank you for that. Yeah, so one of the cool things I really love about generative AI is, and I always say is that when it's done, is that the only limit is your imagination, and you can build so many things. And some of the things that have really made me some of the builds that I really love are these agent builders, and this range a whole across a lot of things. So if you code, it's the Windsurf, it's the Casa, it's the Cloud Code. How those things are, it's a lovable. How those things are built is just amazing. And the next level is seeing also all these others that you can do no code builds.
So we have the agent builder here by Langchain. And also you have one called N8N. So as I mentioned, I know some of you have definitely played with these things. And yeah, so for those who have not played around with it, you can see how you can build something like this. So you can generally just search them. So one is the agent builder. Just come and search for it, and you can create an agent. So and it's as easy as so here I can chat with my chat agent I created a market research agent analyst that does market research for me. So you can imagine how long it will take to do market research. So say you are an analyst and you've been told I need you to do research on API security on the API security market. We want to see which vendors we should bring in. That's a task that will take you at least a day to come up with something interesting. But to do some of these things, it will do so in 10 minutes or at most 20 minutes. And it will give you something substantive that if you go through, it's not work you'll have done within the same amount of time. And this agent builders, you can just come here, create a new agent. And the interesting thing, so yeah, definitely to tell me this. Yeah, but what you can do is if I click real quick, you'll see something. It's gone back there. It allows you to create an agent even through Word. Like you can just write a prompt, a beautiful prompt. And remember what I mentioned, garbage in, garbage out. It's only as good as the information you give it. So when you give it really, really crisp and really, really understandable information, it will give you an output that makes sense. So imagine this way, if you're talking to someone, how will you explain something they don't know in a way that they'll understand and not ask a follow-up question? You need to be very clear, you need to give examples, and you need to give some context. So the same way you talk to someone about something they don't know and you don't want them to ask a question back, and how you tell them in a very clear manner is the same way you need to prompt. Yeah. So I did not build this agent in by drag and drop, which is also a really cool thing that you can do with these things. I just wrote a message and it created this. It created for me a market research analyst, did all these things, where now, if I ask a question, and you can see here, let me just collapse this menu. If I ask a question, I create an analysis of the API security market. It gives me a whole report with the executive summary, a market overview, a market segment by components, market definition by scope, all these things, all this information. It is a lot to look at. And even gives me the data sources and confidence assessment, such that I can verify the output. So you can imagine if I was to do this, this took me from creating the agent through Word and asking it the question and it giving me an output. It took me 20 minutes. And most of that time was taken during the research by the agent. And you can see, definitely creates something. And for me, I thought about doing a market research analyst. And as I mentioned before, the limit is your creativity. What could you create? What problem have you been thinking about? What idea have you been thinking about that you can create and play around with generative AI? So do give it a try. And this is Agent Builder by Lansmith. Another one is N8N. And N8N is another one where it has a lot of the same, it's similar to that. So here, as you can see, you have N8N AI, similar to it. You can create something. So you can either ask a question around N8N, or you can also build using it. Very cool feature. Even if you're not thinking of using the generative AI, like the engineering and how the people are thinking is also quite really cool. And you can create either by text, similar to the agent builder by LangChain, or you can drag and drop nodes and test them out. So in this case, what I've done is I created a trigger where I want to interact with this agent. So when chat message is received, and then touch an AI agent. And remember, I mentioned with the AI agent is that you can have the model as a brain. In this case, I put Anthropic, so Claude by Anthropic. You need memory and to give it a tool. A tool is something to act. In order to do the same thing, where I was creating a market research agent, and in this case, I gave it the ability to search the web. Similar to yourself, you would do market research by searching the web. So I basically gave it this. Then I gave it instructions. You're an expert market research agent that does all these things. And then once that happens, you give it a query. So I didn't quite fine tune this as it was getting to 100 iterations, and those are my max iterations. But that's the other thing about building with these things. It's never the first try it works. You have to keep trying, and that's the reason why I had to keep this error as well, so that I can show you also the processes that we go through. You hit a blocker, you adjust. You hit a blocker, you adjust. You hit a blocker, you adjust. So another cool thing about N8N that I wanted to see and around this query again is that it sort of, as you're working with it, it shows you how it's working. So even if you're trying to learn how to build things or how things work, it sort of gives you a visual as to how it works, and you'll see how it does so. So as you can see, I've sent a chat message. It goes to my AI agent. It's currently thinking, and it's thinking using the model. It decides it needs to use my tool to search the web. Now it's using my tool, and then once it uses my tool, it will come back to the model, and it will keep iterating like this until it's able to be satisfied that we have definitely gotten our answer, and therefore we can give the user a response. So you can see it used a tool, it came back to the model, and the model keeps thinking. Sends to memory, comes back. You can be able to see how it's working. And this is sort of like the cool thing about N8N. And feel free to play around with it. And if you come to the side, what's this? They all have one thing in common. They have various templates that they have lots and lots of templates that you can go through and just see what other people are building, and you can try them out. So you can click here, see more templates. Let's see, discover 912 operation or IT ops automation workflows. And you can just come here and have a view, test them out, and play around with them, right? Still hasn't finished, but due to time, I'll stop there and go back to my presentation to sort of conclude. So within this, how do I encourage you to get started? So to get started, one, I believe you need very strong software engineering skills. You'll realize generative AI becomes more, the most data science, it becomes more problem solving and more and a lot around software engineering. You're solving a lot of problems. You're thinking around scalability. You're thinking about efficiency. You're thinking, how do I not get prompt injected? On the data science side, there's a lot around probability. How will it answer? How do I cater for that? How do I measure its accuracy and how it responds and etc. It's a very good balance between the two, and it's a very interesting field because the things you can build with it are exponential, in my opinion. And as I mentioned, the limit is your imagination. And therefore, what I can encourage you is try one tool. I've shown you two: Langsmith, Langsmith Agent Builder, and it. And any tool, just try it and experience it and play around with it. Ask yourself as well and try and reverse engineer it. How was it built? Etc. Then identify one process or one problem that you have for fun, that you can use to improve and try and build using um, some of these tools. Next, learn a hero prompt engineering, but take it as context engineering. It's a concept. Context is king. How do you feel? How does Cloud Code understand your whole code base? How does that work? How Ask yourself those questions, and then take on a big project. And I've put here some resources to explore. So you can use Anthropic Prompt Engineering Guide. It's a very good one. You can also check their engineering page in itself. It has very nice um, articles around context engineering, around how to build effective agents. The engineering blog is amazing. So have a look at that. You can look at,
Excuse me.
yeah.
Just a minute. I think the slide we're seeing is the demo one.
Oh, wow. Okay. Has it shifted? Not yet.
Not yet, not yet. Hello. Is it just on my end, or did we all lose him?
We've lost him.
Okay. Okay, let's give him a few minutes to sort that out. We can be sharing our questions under Q&A and also have your questions lined up so that when he opens Q&A, the Q&A session, it goes smoothly.
Can you hear me now? Are you able to hear me?
Yes.
Yes.
Yes. All right. Apologies for that. So let me share my screen. Okay. So right now you're able to see the getting started with generative AI.
Yes.
Right. Okay. So my video is off as Teams has apparently refused to turn it on, but no problem. We shall proceed. Now I was mentioning that you can try a tool, the tools I've showed you, and you can play around with them to build something. Next, you can identify a process at work or even in your personal that you can play around with. Even in the templates, you can play around with one template. You can learn the prompt engineering fundamentals and look at also some of the resources down here. And then in a quarter, try and build one project end to end. Right? Peter, I see you have a question. All right. So some resources you can explore. You can check out Anthropic's prompt engineering, and you can also check out the engineering blog. You can check out the deep learning and deep learning AI courses. There are very many resources there. Have a look at them. And two that I like that are really quick is you have the Kaggle Agentic course and also the Kaggle Gen AI course. You can have a look at those, and those will be very, very helpful. So the 5 things to remember: Gen AI amplifies, doesn't replace. Always start with the problem, not the technology. Context engineering is a skill. It's a very important one in all this, whether it's direct API calls, retrieval augmented generation, or agentic. How you engineer your context is very key. And simple always beats complex. And security matters. Always start with security. And now I am done and open the floor up for questions here.
Thank you. Thank you so much for the wonderful presentation. As we await those who are asking the questions, we have one on the Q&A that is asking, okay, I don't think it's quite clear. Noah is asking, where do we deep fix? Noah, kindly if you could clarify exactly what your question is. In the meantime, the rest of the team is free to ask questions.
Hello. Is anyone speaking? Because siwaski anyone. Hello.
Hello,
That would be you.
hello, Sifa, can you hear us?
Kuna mtu anaongea?
Can the rest of the team hear us?
I can hear you, Hope.
Hello.
Okay.
I can hear you, Sifa.
Any questions? Go ahead, Mark.
Can you hear me? Yes. So I think my questions are two, and one would be: you said that generative AI can be subject to prompt injection. So I guess the question would be: how then do you secure your sensitive data when using Gen AI tools? And then the other one would be, uh, like how is generative AI a contribution to misinformation or bias?
Okay, thank you for your question. So I'll answer the first question. Yes, it's very prone to prompt injection. And the layers to how you prevent this prompt injection. So one is you use a model that already is built with security in mind. So for example, if you look at the prompt injection statistics, you find that cloud models are built with security in mind. So one, if you build a cloud model, you're less likely to be prone to prompt injection. So, and then the other level of prompt injection is that you can add it in the prompt. So in the prompt of your model, you can tell the model not to divulge certain levels of information. That's another layer. Another layer is you can sanitize the inputs that get into your model. So for example, if there's SQL injection, etc., you can be able to detect this input getting it before it even reaches your model and either block it off or either block it off or sanitize it. So most you can use that as a technique. Another one is use guardrails. So for example, AWS have guardrails. So you create a guardrail that is able to detect hate, it's able to detect to violence, it's able to detect profanity, it's also able to detect prompt injection. And you can also give it also other topics it needs to understand and reject. And when you have all these layers, you become less prone to prompt injection. That's how you build. That's how you can build to try and avoid that. The other question is yes, it's prone to misinformation and bias, in the fact that, and I mentioned this, if you don't, you need to verify the output. So you can imagine it's trained on the internet's data. Already the internet is biased. So it has some bias to it. It will only be unbiased if it's trained on data that's not biased. And we ourselves as humans are biased, and we've created things that we definitely create something that has bias on it. So definitely what happens is in the training, they've tried as much as possible to create the training data in a way that doesn't have so much bias and try to be very responsible in building this. But it will have, we cannot say it's zero, it's you cannot you're not prone to misinformation and bias. There definitely will be some bias and there definitely will be some misinformation. And these are some of the risks that come with generative AI. And therefore it calls upon us not only to be not only to build with not only to build using them in a way that uh, helps us, but also to be privy of this misinformation, this bias, and also to build responsibly and as well not build responsibly, but consume also responsibly. I hope I've answered your questions now.
Yes.
Evening. I was asking, how do you assess that your model is working fine, and what are the things to look for as a metric of success?
All right. So it depends on your use case. So some use cases. So say for example, let's say the direct API calls. So if you are trying to predict sentiments using Gen AI, you just need to have like a validation data set and you run your tests around it. So say you have a validation data set that has text and also the sentiments, like yes or no, yes or no. I mean, and then the sentiment like toxic, non-toxic, toxic, non-toxic. So you run Gen AI to detect whether it's toxic or non-toxic, and then you compare the results from Gen AI and this ones to check how accurate it is. Another example is, say, when you're trying to classify receipts as well. Now you just have to verify how accurate it is. You just use accuracy. In other use cases, now say retrieval augmented generation, where it's getting information from it's getting it's retrieving information from your documents. You can measure using some metrics such as RAGAS. You can also check for relevance and also how good it is at retrieving your information. So what I mean now by all of this is that there are so many metrics out there that can be used to evaluate how accurate how good your models are, and it's very specific to the particular use case that you have. For agentic use cases, at times it's good to test them through. You test them. How you can test them is that you test them through the edge cases, and then just review the information that it outputs, and then from that you can be able to extrapolate and see how is this thing actually thinking. And there are very many platforms out there that help you evaluate this. So there's Arise AI, and there's also on Bedrock AWS, you can also do such things. And yeah, so that's basically it. Another interesting way that people use, but it's also quite expensive, is you use another LLM as a judge. So you use another LLM to judge the output, especially where you can't find really definitive metrics to sort of evaluate your model. You can have another LLM evaluate the output of your LLM. So sort of like the way you have in a classroom, you are students, and then you have a teacher who's just a human like you, but they're just more experienced. So you could have a much more powerful LLM evaluate this lower LLM's output. Yeah.
Thank you. There's a question from Julie on the chat asking, can AI help in giving data sets on a specific area? And if so, which platform is appropriate?
Right. So yes, AI can be used to generate synthetic data. So I'm trying to look. There's usually a platform that I know. Trying to remember its name. I believe it's called Gretel. You can generate synthetic. There are so many. You can just search synthetic data generating apps. So there are those tools that generate synthetic data. So one, you can do that. Another interesting way that I do is I have an LLM create for me code to create synthetic data. And then I run that code, which creates synthetic data. So you can use those two ways. So that you can use the tools that are out there to generate synthetic data, or you can have an LLM write you code that generates synthetic data. Yeah. So those two ways I've seen work for me, but I mostly use the second bit.
Thank you. Another question from Prince. In matters of security, how does one verify any AI tool's credibility?
So one is from the metrics that you place. So as I mentioned, based on the use case, you have accuracy. Another one is you verify it yourself, or you have another LLM as a judge. Other use cases that are quite critical is where, and you see it as one of the risks that are in the OWASP 10 for LLMs, is full autonomy. So in other use cases where it's very you don't want the large language model to make the decisions. What you do is that you put in the human as a loop. So the model does all these things, and then instead of actioning it, it passes it through a human to verify it. In other instances, you find that you give it a confidence score, where if it's not that confident in giving the answer, like say you tell it you only do this if you have like 90% confidence. If not, hit an API that targets it to a human. So those various ways. So in metrics like accuracy, if it meets your accuracy benchmark, if your use case can allow you to check using accuracy as a metric, then that's good. If you don't really, if you're comfortable using LLM as a judge, that's also good. But if you're not really comfortable with the large language model making decisions, you can have it have like you can create a logic gate where if the confidence is not this, if it's if the confidence is below this, um, if the confidence is below this, pass it to a human. If not, action it, or you can even have the human as a human in the loop where always the output has to go through a human. So you can use those various tactics. Okay.
Yes. Let me ask the last question, which is ethical and ethical question. So, who is responsible for harm caused by generative AI outputs? Will we say it's the developer or the deployer or the user? And then the second one would be for agents that operate with black boxes, models. So how can transparency be enforced? And then the last one would be now for agents, I believe, I'm not sure, but the smaller the agent, the easier it is usually to manage performance wise. Small agents tend to be more accurate. Like for example, your marketing one. Now, what happens for the bigger data? The bigger data then becomes harder, right? Performance wise. So what are the trade-offs between performance and size and cost?
Okay. So I'll answer your questions. So the three questions. I'll start with the first one. Who takes responsibility? So in this case, I believe everyone is usually hurt. The user is hurt, the developer is hurt, and also the maker of the model is hurt. But mostly it comes back to you as a person, and that's how you encourage the ethical use of AI. As a user, how do you ensure you use it ethically, so that it doesn't harm you? That's one way. For the developer, how do you build using generative AI in a way that it doesn't harm you? So it doesn't harm the user, the person you intend to use this particular model. So because, for example, Claude, before they give you the Claude model, they have done everything to ensure that it's safe. Like right now, if you try and prompt inject Claude when you're interacting with it will be quite hard. But this is something they have purpose to do on their end. And when they give it to you as well, it doesn't it's for you now to ensure that you build upon it as well and emphasize the ethics around it. Like build with it and put those gates, put those guardrails such that if a user is trying to be hateful and is not trying to be ethical, you're able to block that so that you don't take that responsibility. Because the moment they say something hateful and you remember it responds close with the next probable word, they'll say you are the problem and will not take responsibility. So it's very ethical, it's very personal. So even as you're building, you have to think about it in an ethically, build in a way that you anticipate these users and you make sure you put in the guardrails to ensure that doesn't happen. The other one is how do you enforce transparency? with these models. So what I have realized from my experience is extensive monitoring and logging. So don't just log using ELK, CloudWatch, you're just monitoring how the app works. There are some very, very nice um, monitoring tools out there. Langsmith is one of them. There are very many open source ones such as Langfuse, MLflow. And what these tools do is that you're able to trace how the model works. So for example, as if you remember during the demo for N8N, you could be able to see the agent working, and then the logs you're able to see the agent, and then it calls the client. There's a lot of I can be able to observe what it's actually doing at any particular point, and I'm able to trace all those things. So normally with this black box model, what we do is that we use those observability platforms like Langfuse, in addition to CloudWatch and ELK, to monitor probably how the app is working. We're able to monitor for every query, how is this agent, uh, how is this agent, how is this model working, how is it taking in the input and giving an output, or what input. And from all these things, on a weekly basis, we can analyze and see here probably it responded well, here it didn't respond well, why didn't it respond well in this case? Is it something the user said? Is it something that probably is in the prompt that we gave it that is causing it to respond like this? So we do get some transparency based on the traces that we log. And then smaller agents compared to larger agents. So larger models are definitely more accurate compared to smaller models. But now when you come to agentic workflows, I mentioned simpler is always better than complex. So the more simple it is, the easier it is for you to trace its operations and know and know where it went well and where it went wrong. For example, if you have one agent, if it goes wrong once. But if you have many agents, and that's why like in the level of complexity, it was autonomous agents. If one error is created, that error is likely to propagate. So there's some complexity in terms of engineering and requires a lot of skill to architect such systems. However, such systems can also be very impactful. So you can also say if it's accurate or not accurate. Like simpler is more accurate than complex. It also depends on the use case. There are some use cases where if you use a simple agent, it won't work. When you use a complex agent, it will work. So meaning it's much better at that. And you find some use cases, a simpler agent is much better than a complex agent. So it's usually better to start simple and iterate to try and meet your goal. Start simple and make it complex as you're trying to achieve a goal. Only make it complex if complexity helps you increase the accuracy. But you cannot generally say whether small agents are more accurate than bigger agents. It depends on the use case as well.
Thank you. But it's okay. It's fine. I think the first question there's thanks for the second and the third. The first question was I don't know. Let me give you a scenario. Like let's say you've integrated OpenAI with your Windows, right? So they're working simultaneously to help you in your tasks quickly. Now, let's say it's rare because they're a big company. Let's say they do have a malfunction in the system, or they set their agent wrongly, or maybe he has hallucinations, or all those AI errors. Now, me as the user, I use it, not even maliciously. Let's say I'm using it for work, right? And then the agent happens to let's say I'm in security, and then it happens to make a fall or a blunder. Now, the question I want to ask was that let's say they're suing, am I the one being sued, or can I again say it wasn't me, it was the model?
So if so, normally here it becomes a low question, because this is usually debated a lot, especially when it comes to like the in the AI community. And you'll find how often these model builders will show themselves is through they'll definitely have their lawyers there, and also they give you like their usage guidelines. So, well, when they give you the model, they know it hallucinates, and if you know, what you'll find is some of these models, if you're using them, they tell you it's prone to making mistakes. They give you a caveat there. So if you come and say it made a mistake, they'll tell you, but we told you. You get. And then for yourself, you also take some responsibility, because if in the case that it's realized that you did have like poor system design, or you didn't validate the outputs before deployment, you didn't do adequate prompt engineering, you misrepresented the system capability to end users. You told users this thing is like a magic wand. You see, now that's an issue on your end as well. And the end user as well, they misuse the system. So you cannot shift the blame pure entirely on one person, because there's there are several aspects to it, and people show themselves in one way or another around it. Yeah.
Okay, thank you.
Okay, so we can have Amido as the last question for the night.
Hello, good evening. Can you hear me?
Yeah.
Okay. Kimani, thanks very much for the great presentation. I have a few questions, actually related to AI governance, risk, and all. First, I want to ask, what does effective AI governance look like in practice today for generative AI? I mean, beyond policy documents, and how are teams operationalizing things like approval workflows, auditability, and model usage controls? And also, for teams building internal generative AI platforms, what patterns have you seen for centralizing governance, such as prompt management, access control, rate limiting, and observability without slowing down developers? I don't know. I think I have like one or two more questions, but maybe you can give you time to respond.
Yeah. So what I've seen is definitely like in an organizational level, there are various gates that you have to pass. That's what I've seen governance being like. So one, you have the data gates, you have the developers gate, and you have cybersecurity. And these are very key stakeholders in ensuring ethical AI. So when it comes to the data, people what they do, and when you have conversations with them, is they ensure that you're not misusing the data, or you're not using customer data, or in a way that exposes them. You're not you check how is this data being used? Is privacy being enforced here? So those are key bits. When you come to the developers, there are levels to the developers. So the juniors, there are the seniors, and we do have peer reviews where we go through people's codes and try and pinpoint where something could often be off, or could be quite, if let go, it can be quite painful. So we do have those gates. There's a lot of observability. So where we not only use this log monitoring ones, but we also trace our models. So as I mentioned, some platforms such as Langsmith, Langfuse, we test those models and we thoroughly test them. So I don't just create a system and deploy it to production. I have to thoroughly test it to ensure that, and it has to have this. There has to be a report that you thoroughly tested it, and there has to be a report that it's actually secure. And this comes now from having cybersecurity now do checks where they do tests like prompt injecting to ensure that, yeah, this thing is actually safe to give to people to use. And there are so many things we have to fill in to do. We also do a risk assessment as well to ensure that it's not too risky to go out there. And some of these gates, yes, they slow down development, but I feel like they are quite important because you'd rather go slow, but than have the repercussions come back to you that will be detrimental not only to the company but also to yourself. So you'd rather build something and build right, even if it takes you go through those gates. So it's a cost that you have to bear. The other question was the second question. Can you remind me?
I don't know, but it looks like you answered some parts of actually the second question. The first question was around governance and risk focused. Yeah, I was asking the effective, like how does effective AI governance look like in practice? But you just mentioned that, and it's like you also jumped into the second question, talking about observability and all, and the access control. So just that you didn't, I don't know, I might have had an oversight, but maybe you didn't talk about rates limiting.
All right. Oh, so in rate limiting, yeah. So that depends as well on your model. So if you realize, depending on how you expose your model, it's usually very key to use things like API gateways. So like, for example, the good thing with API gateways is that you can be able to create like usage plans. And in these usage plans, you are able to like say, you can be able to adjust how many requests per minute your API should receive. And this sort of, what it does is that it does the rate limiting. So it controls the access to the model. So in some use cases, you can do like 10 requests. In some use cases, you can even take it to like 2,000. And it's very dependent. So, and that helps you as well control the costs, because you can find someone can try and consistently hit your API, causing you guys to lose a lot of revenue and incur so many costs. So I believe the best way I do it is through using API gateways.
Okay, well, actually, I think it's just one more question, this just for clarification. So like, as generative AI systems increasingly rely on third-party models and APIs, how are organizations managing, from your own experience, how are organizations managing vendor risk and dependency, especially around model changes, outages, and long-term governance?
So how organizations are managing this is, one, using a reliable provider. So for example, Claude, when you use Claude, it has a reliable provider. Rarely will you have it down. And then you can also consume it off organizations that are very dependable. So you can consume it off AWS, you can consume it off Azure, you can consume it off Google Cloud. So partnering with companies with very good reputation is one way that you ensure that you continue, that you don't really face issues when it comes to like something going down. The other is with the constant release of models, you have to just keep on track. And if one model works properly, why change? You don't need to really change. If Claude 3.5 works properly, why change to 4.0 or 4.5 when it works when Claude 3.5 works well? And if a smaller model works great, why shift to a bigger model? So you have to experiment a lot and see what works for you. And it's really guided a lot by the business as well. So say you cannot use a hammer to kill a cockroach. So you could be using something simple like extracting information from receipts. You do not need a Claude 4.5 Sonnet or Claude 4.5 Opus to do that. You can easily do that with a Claude 3 Haiku, which is much cheaper. So start with the cheap models first as you scale, and if it works, stay with it unless it has given you issues. Yeah.
Okay, no problem. Thank you. Thank you. So based on this, because from your explanation, Claude seems to be the best model so far, and also for my own experience, because I've been using it for quite some time now. I've compared with all other models, including the ChatGPT, some people normally hype. I don't know, but Claude seems to be the best. But how would you compare it to other models, including the ChatGPT itself, the recent models, the recent versions released, I think 5.2 or so, ChatGPT and the others, DeepSeek, Quen, how would you compare in your own opinion?
Yeah, so different models work differently, also for different use cases. For example, if it's anything vision related, Gemini is really, really, really good. Anything vision related, Gemini will always be king. If it's, I've tried out some of these open source models. I've seen Quen really do well, and DeepSeek, especially when it comes to the understanding of low resource languages. So, for example, you can tell DeepSeek sort of like to talk in Kisii, and it will talk in Kisii. It will actually be pretty good, or talk in Sheng. It will actually be pretty good. I've seen that. But for me, overall, I'm a huge advocate of Claude 4.5. It's never let me down. So, yeah, hopefully they can give me free credits for a month for overusing it. But yeah, it's a model I really advocate. It works well for almost most of the use cases that you use. Claude 4.5 Sonnet, or if you have a lot of money, Claude 4.5 Opus also works well. It's the most intelligent in their catalog of models.
Yeah, actually myself, or my experience, I think that's it. I also use that. So for African languages, so assuming someone is developing an app, of course, I'm actually working on something similar to that. Like a mobile app for African languages, for what constitutes in African languages, something similar to Duolingo. So which model would you recommend that would be very good in African languages, in translation, and so that would be good in teaching African languages of all type, even though it might not be all African languages, but those commonly known African languages. Which model would you recommend?
So
Free and paid, free or paid model?
Or free or paid model. So
Yeah.
from my experiments, what I've seen work really good. Still, there is some limitation, but some that are working really good that I've seen of work really good is I've seen 4.5 Opus really work well. However, it's quite an expensive model. The other one I've seen is a top tier DeepSeek model that has also works well. So you can experiment with those two and see. Yeah.
Thank you. Thank you so
Okay,
much.
thank you very much. Thank you very much. Thank you.
Okay. So I'll give it back to you to just give parting shots before I bring the session to a close. Thank you for taking the time to explain it, the whole session in a way that is very understandable to us. I believe most of our questions on this topic have been answered. Personally, I came in with a very green perspective and I've come out with a lot of knowledge. So thank you for that. And thank you for taking our questions. So give us your last parting short words.
So thank you everyone for making the time. You have made the time this evening to really come here, listen to me, and also for inviting me. So it was a huge pleasure to talk to all of you. My parting shot will be build ethically, build responsibly, and as you do so, let your only limit be your imagination. There's a lot that you can do. Generative AI and AI in whole will help, I believe, will help civilization grow exponentially. And that's because a lot of the things that we can imagine, we can build fast and we can now even build. So do not let your imagination be cut short. Build, but build ethically. And thank you so much. Back to you, Hope.
Thank you so much as well. So kindly share with me the presentation slides so that I can share with the students. Apart from that, thank you again for doing this session. It's been a real pleasure having you on the session. Hopefully we can have you back for maybe an extensive view on more details and maybe more practical after we've done our own research and whatever worked on certain things. So thank you so much everyone for joining the session. I hope we've come out with something. As usual, I encourage you to listen to the recording. It's always on YouTube by the next week. So feel free to listen to the recording, internalize, and also reach out. So just beyond the 1 hour sessions, we encourage you to reach out to the mentor when you can, build your information on this, and also have a personal guide for yourself. So just like Kimani said, this is the new electricity, so it's not going, it's here to stay, and we have to be part of it. So make the best out of the information you've gained and have a lovely night, everyone. Okay, thank you. Bye. See you next Thursday.